Let's try PDO then. PD is what? PD is not lead. PB is lead. Oh, it was up here. Palladium. Is that how you spell it? Okay. Is palladium a transition metal?
Yes.
Indeed it is. So we'll need to make sure we have the parentheses. O indicates oxide. And now we have to figure out what value for our Roman numeral needs to go in the parentheses. This will be based off of the charges. So what charge does oxygen have on it? Negative what? 2. And so in order for palladium oxide to be a balanced compound, what charge does palladium have to have? A positive 2. So this charge, this 2, gets entered into the parentheses as a Roman numeral.
No, we don't need any symbol to indicate plus or minus.
Correct. It's just known that it will be the positive charge. We don't need to put the positive or negative in there. Very good. Hallie?
So, because on the second one we did the charge based on what oxygen was, right?
Yes.
So how come we did it for what silver was for the first one?
Well, we could have done it the same way. So if we looked at sulfur's charge is negative 2,
Yeah.
and silver's charge is positive 1 because of the rule, but because of this 2 times the positive 1 gives us a total positive 2 charge. But we just want to know what a single silver ion's charge is when we put it in here. So the charge that goes in the parentheses is if it were only one ion, not however many ions you need to balance out the overall compound. Do we want to look at PTCl4? Or are we feeling confident? Not confident or not look at it? Look at it. Okay, so PT is platinum. Is platinum a transition metal?
Yeah.
Yep, so then we need the parentheses. Chlorine becomes chloride. What's the charge on chloride? No. Negative what? Negative 1 for an overall charge of, taking into account the total number of chlorine ions. So 4 times the negative 1 gives us our overall charge of negative 4. So how many platinum ions do we have in this particular example? Is there any subscripts on platinum? No, so that means that there's only 1. So 1 times what gives us a positive 4? 1 times what gives us a positive 4? 4, right? 1 times 4 equals 4. So that means your charge on platinum has to be positive 4. So that 4 is what will be indicated in the Roman numerals. Okay, let's look at vanadium here. V is vanadium. Is vanadium a transition metal? Yep, so we have to put the parentheses. O5 indicates what ion? Oxygen, but that oxide, good. Okay, what's the normal charge on one oxide ion? Negative 2. So that gives us a negative charge of negative 10. So we need vanadium to have a positive 10 charge. So what charge would be on a single vanadium? 5. So the 5 is what gets written here. Ternary compounds. These are ionic compounds composed of 3 or more elements. This will include your polyatomic ions. A polyatomic ion is an ion composed of more than one atom. If we're looking at its word name, it usually has an ending of ate or ite. And then you can have these oxoanions, and this is when there are 2 common oxoanions for a particular element. The one with more oxygen atoms gets the ate suffix, ate, while the one with fewer oxygen atoms gets the ite suffix. So this list right here, this is a pretty complete list of polyatomic ions. It lists the word name, the symbols, or the elements that are composed or used to make up this polyatomic ion, as well as the charges. The charges are listed as your column header. So everything in that first column has a -1 charge. Does that make sense? This table will be provided to you on tests or quizzes. Okay? So, to practice naming the following compounds. You will need to look up and see if there are any polyatomics. So, a general rule of thumb to help you with this. Generally, your polyatomics are written second. The exception, NH4+. That is the one polyatomic that gets written first. The reason it gets written first is because it is a cation. The cations always get written first. So that leads us to this example, which is the exception to the rule because we see it's NH4 to start with. NH4, you look up on the chart, is called ammonium. And then you have to look up this polyatomic right here. So if you look on the chart, what is this polyatomic? Nitrate, very good. Does that make sense? How to use that chart? Okay. Let's look at this second one quickly. You name the cation first. The cation in this case is Na2. So what is Na2 as a name in words? Sodium. And then you look up the cation, you look up the anion on your polyatomic chart. Cr2O7. No. Cr2. Dichromate. And that's really all there is to it, except in our next example, Pb is lead. Lead gets treated like a transition metal. And then you name your CO3. You look that one up on the chart. Carbonate. Good. So you just write carbonate. And then you have to figure out what charge or what Roman numerals needs to go in the parentheses. Looking up carbonate, what is the charge on that? -2. And so what does the charge on the lead have to be to balance out that -2? +2. Very good. Okay. I'm going to skip that next example because I want to do it from words to symbols. So, when we do the words to symbols, we have to make sure we remember to balance the charges. That means the charge has to equal 0. So, potassium, K, hydrogen sulfide, we're going to pull from your polyatomic list. So what is the symbols for hydrogen sulfide? HS, isn't it? HS with a minus sign. So that minus sign indicates the charge on that whole polyatomic. So then to figure out the charge on your cation, or potassium in this case, you need to look at the periodic table. What is the charge on potassium? +1. So we have a positive one and a negative one. That balances out to 0. So then our overall answer here is KHS. Okay. Looking at our next example, iron 3 oxalate. Iron. What does this Roman numeral 3 indicate for us about iron? It has a positive 3 charge. And then you'll have to look up oxalate on your polyatomic chart. C2O4, and its charge is -2. Do we balance out to 0 here? No. So that means we need to add subscripts to our overall formula. So what subscript do we need on iron to balance out to help make it 0? A 2, very good. And what subscript needs to go on the oxalate? It's always a positive number on the subscripts, but yes, it is 3. So when you add a subscript to a polyatomic, what you need to make sure you do is you need to put the polyatomic in parentheses and then place the subscript. That indicates then that this subscript gets distributed to any and all elements within that parentheses. A trick here to help you not have to do the math. Generally speaking, whatever the charge on your cation is will become your subscript on your anion. The crisscross method, yes. The charge on your anion will generally become the subscript on your cation. This does not work for examples like this first one where everything is same, 1-to-1. Okay? There are some where it will not work. Are there any questions?